Imagine searching for a video not by keywords, but by story. A red liquid pouring into a mixer, then bubbling into pink foam. You don't type red liquid mixer foam. You describe the moment, the motion, the transformation. And the AI finds it exactly. This isn't science fiction. It's happening now, thanks to a breakthrough in multimodal AI, a system that doesn't just match data but understands it. At the heart of this revolution are multimodal embeddings, a way to translate text, images, and videos into a shared numerical language. Think of it as giving every piece of media a meaning fingerprint. Now the AI can compare a caption to a frame, a sentence to a scene, or a query to a moment in time, because they all live in the same space. But most models still just guess. They look for keywords, patterns, or surface-level similarities. They don't think. Until now, researchers from Tsinghua University and Kuaishou Technology have introduced Embed-RL, a new framework that teaches AI to reason before it retrieves. Not just find me a bottle, but the image shows a glass of cola. No orange bottle here. So the match must be a different image, where an orange Fanta bottle replaces the glass. This isn't just a description. It's a chain of reasoning. And Embed-RL doesn't just generate it, it optimizes it using reinforcement learning. Here's how it works. The model starts by analyzing the query and the media. It builds a traceability chain-of-thought, or T-CoT, a step-by-step log of what it sees, why it matters, and what evidence it's using. But unlike traditional reasoning paths, T-CoTs are grounded in real visual and temporal signals. It draws bounding boxes around key objects. It highlights the exact frame where an action occurs. It pinpoints spatial relationships. The bowl is to the left of the bread. It tracks temporal dynamics. The jump happens at frame 127. This is evidential traceability, a map of why the model thinks something matches. And here's where the real innovation kicks in. The model isn't just generating this chain. It's learning to improve it. Using a dual reward system, the AI gets feedback on two fronts. First, how well the reasoning aligns with the visual evidence. Does the logic match what's actually in the image or video? Second, how well the final retrieval performs. Does the returned result truly match the query? Every time the model produces a more accurate, better structured T-CoT, it gets a reward. Over time, it learns to focus on what matters, not just words, but real, extractable evidence. This isn't just smarter. It's self-correcting. Let's look at the results. On the UVRB benchmark, a massive test of multimodal retrieval across 7 key dimensions, Embed-RL 7B outperformed every other model, including Clip-4-Clip, VideoClip-XL, and even larger, more complex architectures. It scored 55.9 on the average metric, significantly ahead of the competition. But more impressive than the number, the quality of the reasoning. Take one example. Query, what fruit is to the right of an empty crate? Before reinforcement learning, the model said apples. After, it correctly identifies bananas and draws the bounding box to prove it. Another, a video of a girl doing gymnastics. Before, the model returned every frame, including a hug at the end. After, it isolates only the key actions, cartwheels, handstands, jumps, ignoring irrelevant moments. Why? Because the model now understands the task. It's not chasing keywords. It's chasing meaning. And the training data shows it. As the model learned, its reasoning entropy dropped, meaning its logic became more focused, less random. Its response length increased, not because it was verbose, but because it was adding meaningful steps. And its reward signal climbed steadily, a clear sign the reasoning process was improving. But here's the most practical breakthrough. T-CoTs are generated once, stored, and reused. Unlike other models that recompute reasoning every time, Embed-RL treats the reasoning chain like a digital fingerprint. Once created, it's cached. Retrieval becomes instant, no repeated computation, no latency. This isn't just a performance win. It's an architectural shift. Instead of adding complex fusion modules, attention layers, or post-processing pipelines, intelligence is baked directly into the embedding. So when you ask, show me a man throwing a javelin, the model doesn't just scan for man and throwing. It understands the motion, the trajectory, the context, and retrieves only the frames that match both the action and the setting. This is the future of AI, not just pattern recognition, but semantic understanding. Not just retrieval, but reasoning-driven retrieval. And while there's still room to grow, better reward balancing, handling hard negatives, or extending to image classification, this is already a paradigm shift. It proves that reasoning isn't a bonus. It's the foundation. For content discovery, recommendation systems, intelligent assistants, or even AI-powered search engines, this isn't just an upgrade. It's a new way of building AI that gets us. So the next time you ask your AI to find something, don't just describe it. Tell it why it matters. Because now the AI can listen, and understand, and find it exactly